Imagine you're reading a book and the main character suddenly becomes a pancreas. Ridiculous, right? Well, your body actually has cells that can pull off that level of plot twist. We call them stem cells, the shapeshifter of biology. Do you know that your body functions like a corporation? Cells in our body are employees, each assigned with a specific task. For example, heart cells are tasked with beating, neurons zapping, and skin cells forming barriers. But stem cells, they're the interns of biology. They show up like, hi, I can literally do anything. So, scientifically, we've got three main kinds of stem cells. First being embryonic stem cells. They have the potential and ability to become any cell type that your body needs, but are typically only found in developing embryos. Second, we have adult stem cells, which are limited to only becoming cells related to the task they're assigned, but relatively more reliable as they cannot change their roles. You wouldn't want an eye cell to become a stomach cell and produce acid, right? But lastly, we have induced pluripotent stem cells, or iPSCs, which are normal body cells that scientists have reprogrammed to turn back into embryonic stem cells by activating and deactivating certain gene sequences. Basically, they're the return to factory setting option, but for biology. So, why do stem cells matter? Well, with these cells, scientists can grow mini organs called organoids, which are basically tiny mimics of real organs, making them great for research and minimal complaints from actual patients. With this power, stem cells could help us repair damaged organs, regrow neurons to restore motor functions, treat diseases like cancer, and test medicine safely. One day, we might be even able to 3D print organs like a maker ball, but significantly squishier and more practical. Okay, so here's where things get complicated. Some stem cells come from very early stage embryos, so the ethical question becomes, when does a clump of cells deserve protection? Different people give different answers. Some say if the embryos won't be implanted, then using it for research is okay. Others say any embryo, no matter how early, has moral value. Both views come from real beliefs, and that's why the debate matters. Using iPSCs in stem cell research avoid the embryo issue but brings new ones. Could reprogramming cells cause unexpected mutations? Who decide how the technology is used? And the classic, could someone try to clone themselves? So, here's the lesson. Stem cells give medicine and research incredible possibilities, but ethics give us the protective shield so science doesn't accidentally turn into the plot of a sci-fi movie. Understanding both help us move towards breakthroughs that are not only amazing, but also responsible, and ideally with zero surprise pancreases. Thank you for watching.